So in today's lecture, we'll talk about community monitoring of natural resource systems and the environment. My name is Nerea Turreira-Garcia, and I am an assistant professor at the University of Copenhagen. I do research focusing on the inclusion of local ecological knowledge and participatory environmental monitoring and citizen science. In this lecture, I will talk about citizen science and discuss the process of co-designing an environmental monitoring app involving local communities. And the case I will present was developed in Cambodia. And even though I do not mean to compare the case of Cambodia and Ukraine, there are insights that I will share from our case that can be applicable to Ukraine and other contexts as well. So let's start by talking about what is citizen science. In simple terms, citizen science is about involving the public in scientific activities. The words might refer to many different practices as they involve citizens in various stages of the research process. For example, in formulating the idea, in designing the data collection phase, collecting the actual data, or in the analysis and interpretation. Citizen science projects might answer a research question or inform conservation action, management decisions, or environmental policy. And according to Science-Started Hub, there are more than 3,000 citizen science projects in the world, projects, events, and tools, and they engage millions of participants. For example, the citizen science project eBird has more than 5 million observations monthly, and Suniverse has more than 2 million participants. These are just few examples to demonstrate the current extent and impact of citizen science. And volunteers contribute to the field of astronomy, conservation, and environmental science. And most citizen science projects are part of the natural science arena. However, in the recent years, social citizen science is also taking momentum. And they are monitoring societal processes, movements, and human rights violations. So there are three main elements of citizen science. The first is inclusion. The essence of citizen science lies in the active participation of citizens in the scientific research process. Levels of participation can vary, starting from simple contribution of information to collaborative projects involving citizens in data analysis and interpretation, or involving the public in all stages of the research process in co-created projects. The second element is contribution. Gathering large amounts of data over wide geographic areas is beneficial for science and for getting new findings. The benefits for the public include acquiring new skills and knowledge, hands-on understanding of scientific processes, and a sense of achievement and pleasure in individual contribution to science. The third element is reciprocity. Citizen science can potentially promote a two-way communication between researchers and the public and can help citizens understand scientific processes. It can also allow to share data easily. And this two-way dialogue emphasizes democratizing science, determining public desires and needs, encouraging transparency, and encouraging collective decision-making. Since it emerged, citizen science has been shaped according to two main trends: technological ubiquity and social changes. Due to relatively recent technical developments like internet, GPS, development of new sensors, availability of mobile devices, smartphones, high-resolution cameras, and digital platforms, as well as a series of social trends, for example, the increase of literacy levels and growth of number of people with secondary and even tertiary education, have lowered the entry barrier for science and have consequently have a major impact in the ways in which citizen science is currently practiced. Citizen science has become more accessible, but not necessarily more inclusive. As people with low literacy levels and have no access to technology are not part of the general movement of citizen science. To make these points clear, on the left, you can see a representation of citizen science projects, which are mainly displayed in the global north. On the right, you can observe the representation of participatory environmental monitoring projects, which are mainly concentrated in the Global South. While these two terms overlap, they do not necessarily mean the same. In the case that I will present today, I will talk about participatory environmental monitoring as a form of citizen science. So to illustrate how to develop an environmental monitoring app involving local communities as a form of citizen science, I will present now a case in Cambodia where I have personally been involved, together with the colleagues that appear in this slide and many other partners. And as you can see in the title, this ICT stands for Information and Communication Technology. And specifically, I will talk about smartphone apps. So let's start talking a bit about Cambodia. Cambodia is globally known for the beautiful Angkor Wat temples. Sorry. Here they are. And unfortunately, also for the Cambodian Civil War that lasted from 1967 to 1975. Perhaps it's a bit less known the natural wealth of Cambodia. There are more than 8,000 species of plants in the country. And each native tree in the country has an indirect value of $3,700 per tree if each of its parts is used to its full potential. Unfortunately, Cambodia is one of the countries with the highest deforestation rate in the world. And massive land grabs and related illegal logging are destroying the forest. This is the forest cover of Cambodia in 1973. Dark green represents the dense forest, light green mixed forest, and orange color is non-forest. This is the forest cover in 2013. The dense forest, or primary forest, is reduced to some areas of the country. These are mainly mountainous areas, and there is only one lowland forest remaining in the country and in the whole Indo-Chinese Peninsula. This is Prairie Lang. Prairie Lang is a 500,000 hectare forest spread across 4 provinces in the central plains of Cambodia. And to understand what this area means, Prairie Lang has an equivalent area of 610,000 football fields. And unfortunately, Prairie Lang loses the equivalent of 20 football fields a day. So lowland forests have a higher deforestation rates than mountainous forests because they are easier to access. This is a closer look into the interior of Prairie Lang. It's composed by very diverse ecosystems and forest types. And as we can see here from the satellite imagery, Prairie Lang has been targeted by loggers for years, and nearly 90,000 hectares of forest were lost between 2002 and 2022, according to Global Forest Watch data. And more than half of that was lost since 2018. This is a worrying trend of unstopping destruction of this forest. You can find in the chat a link for this iForest platform where you can see the deforestation, the forest cover loss or change in Prairie Lang. So Prairie Lang is facing massive deforestation, sometimes as a clear cutting and sometimes as selective logging of highly valuable timber trees, which are valuable economically, but also for the ecosystems and the peoples who use them. To combat such illegal logging, a network of communities, the Prairie Lang Community Network, or PLCN, was formed in the early 2000s and organized patrols of the forest of illegal loggers. The organization was formed by about 500 members who have specific roles. The PLCN used to report their findings and confiscated materials to the local authorities, often with no meaningful response. For example, sewing machines that were marked with a hidden sign would be reconfiscated again sometime after, meaning they were given back to the loggers by the local authorities. Here are some examples of the forest monitoring work of the Prairie Lang Community Network. Sometimes they would say wood left on site, or tractors and trucks transporting wood, or sewing machines. They usually burn the wood and confiscate the machines, and they give warnings to the illegal loggers. So up until 2015, the PLCN were collecting data on illegal logging using notebooks, which were not deemed as real evidence by local authorities, and the notebooks were easily lost. In 2015, thanks to a participatory research project funded by Danita, the University of Copenhagen, together with local and international NGOs and IT company, offered the PLCN the possibility to develop an app together. This app would enable them to collect the same monitoring data they used to collect, but with the added value of having georeferenced evidence of their work. And this data could not be lost or disregarded. So having the PLCN on board with the idea, we started the participatory co-design of the app. I will describe the overall process in detail in the following slides. But first, just to give an overview, first we defined what had to be done, who would be involved in the process and how. We clarified the ethical considerations. We co-designed the app, and we did continuous trainings on how to use the app. We followed continuous evaluation and feedback loops. And with time, we also added new features to the app. The initial workshop, we gathered the stakeholders of the project to understand well the context, how the PLCN had been operating in the past, what we could offer them with the monitoring app, and what were their data gathering wishes, which I will present also in the following slide. In this workshop, we put in the center the needs of the end users of the app, the communities in Prey Line. The IT company also communicated what information they needed in order to do the technical work. In between, there were the NGOs and the researchers, us, who were aiding this communication between the IT company and the end users. We needed to collect the wishes of the communities and translate them into categories, drop-down menus, context-relevant icons, and decision trees. Something tangible for the IT company to work with. This workshop served to clarify the roles and responsibilities, understand each other's views, and build a common goal. And discuss, of course, the data ownership. In order to protect the forest, the PLCN wanted to have evidence of illegal activities that were happening in Nerea. In addition, the PLCN wanted to have evidence of all the natural resources existing in Nerea. It was a way to demonstrate the richness of the forest and that those natural resources were theirs. So note that until then, the government denied any existence of illegal logging and sold hundreds of thousands of hectares for economic land concessions that until then was classified of land as little environmental value. These economic land concessions cut down primary forests and plant plantations of rubber, cassava, and other trees in the name of green growth. Sometimes the plantations do not even happen. Sorry, Jasmine wants to...
Yes, there seems to be an issue with the sound. We're getting comments on it having an echo.
Okay, I will put my headphones.
I'm sorry for just interrupting.
No, thank you for saying. Okay, can you hear me better now?
Could you say something more?
Yes,
yeah.
Okay. If you can tell me also when you stopped hearing me well, I can also go back a bit.
I think the beginning of this slide would be good. So just from PLCN, yeah?
Yeah. Okay. So In order to protect their forest, the PLCN wanted to have evidence of the illegal activities that were happening in prey land. In addition, the PLCN wanted to have evidence of all the natural resources that exist in prey land. And it was a way to demonstrate the richness of their forest and also to demonstrate that those resources are theirs because they use them, they need them for their everyday life and their culture, of course. And note that until then, the government denied any existence of illegal logging and sold hundreds of thousands of hectares of forest to economic land concessions. That maybe they claimed that they would plant to make plantations of cassava and rubber trees and so on, and bring some economic growth. But often the plantations would never happen, and then they were only interested in taking down the trees. So in order to monitor the natural resources, we also needed to compile a list of plant names in local language and identify them with their scientific names, so that we could understand that when local people talk about a tree called Chetian, for us, we call it Dipterocarpus alatus in Latin. So right at the start of the project, we clarified ethical considerations. We explained very well to the PLCN how the data would be stored, who would have access to it. The PLCN is the lead actor of this project, and we were there to empower and support their decisions. And all data collected were the ownership of PLCN. The PLCN decided which data gets disseminated to the public and what does not. And we always ask consent before publishing and before forming any collaboration with other research institutions and other projects. And of course, the data collected are protected from security protocols, and the input of each of the patrollers is anonymized in our databases for security reasons. We chose to use the Sapeli platform to develop our smartphone application, as it was developed specifically to be used by people with limited experience with technology. The application was modified by a local IT company in Cambodia based on the PLCN's input and feedback. The three main categories that the patrollers were interested to document were valuable resources of their forest, such as trees and non-timber forest products, illegal activities, such as logging, poaching, and mining, and reporting interactions with authorities. Each main category had a limited number of subcategories and added extra information. At a later stage, 2 new categories were added to broaden the scope of the monitoring tool. For example, to report climate-related events, and also to report threats or instances of violence to enhance the feeling of security to the patrollers. As you can see in the in this picture, the categories allow people with low literacy levels to navigate the app easily. And now we are going to get an overview of the app. By clicking on the first screen, the user gets the possibility of taking a picture or recording an audio. When doing so, the app automatically records the GPS location and the time and the date, which are reference data of each entry. After that, the user is prompted to categorize their entry. It can be illegal logging, an illegal activity, natural resource, a personal interaction, or a climate event. Let's say that the user clicks on illegal activity, this one. Then the user can still categorize what kind of illegal activity we are talking about, if it was illegal logging, mining, hunting, or fishing. And when clicking on illegal logging, the user can categorize whether it was a clear cut of a field, a single stump, wood left on the ground, or wood being transported. The app has been successful in the sense that it is still being used after 9 years, and it has already recorded more than 60,000 entries. The success has been due to its easiness of use. It has many images. It is very intuitive. As you can see, there is little text written in Khmer, in the local language, and yet we're able to navigate through it. It has been tailored to the needs of end users, and they have been part of the co-design process. This increases also the feeling of ownership. And we put great focus in the design, using context-relevant icons, and doing training of trainers, and we have also maintained continuous communication with the end users. When the entries are uploaded to the database, the data is validated by a team of data managers to ensure that only valid data is being made available to the public. And data managers can exclude an entry because of technical issues with the app, the signal uploading data to the cloud database, for example. So patrollers took a picture or recorded an audio, but it could not upload due to a technical error. The managers can also exclude an entry because the photo does not represent the description of the event, or an event has been recorded twice, and that could be a human error. The managers also validate entries that have a photo or audio recording that matches the entered information. And it is a long and laborious process, but it's essential to keep data quality. In an evaluation through individual questionnaires that happened in 2017, most of the patrollers claimed that they understood the Prairie app, and they felt that they were able to use it correctly after an initial acquaintance period. Half of the patrollers specifically mentioned problems with uploading data as a key concern, and app complexity was greater with each version. There were in total 5 versions of the app, each of them more complicated than the previous one, in petition from the patrollers themselves, that they wanted to record more and more data with more details. And in any case, the proportion of the submitted entries that were successfully validated also increased with time as well. So the app complexity did not hamper the data quality. In our project, we have faced some challenges that are also useful learning experiences. The collected data by the PLCN is politically sensitive, and therefore it has often been opposed by powerful actors. There was also poor network coverage under the canopy when the patrollers were in the forest. Local communities were unable to analyze their own data, and this created a dependency with external allies. And even though it might not be huge funding what is needed, there is still need for some in order to fund petrol, maintenance of vehicles, phones, internet, and so on. And we also faced some language challenges. For our interactions, we needed translators. And there are also differences in the spellings of the tree names in different regions of Prairie. And this also difficult sometimes the data validation process. And finally, also the long-term engagement, in order for this to be successful, has required constant communication and presence by the different actors of the project. And this, for example, was a bit harder during COVID times, but still we maintained communication through chat and Facebook and so on. So we also did a study about who participates in this participatory environmental monitoring and why. And we found that not all local people are willing to participate in forest monitoring. The ones that actively engage are mainly forest users directly affected by deforestation. Weak institutional conservation strategy also pushes local people to take action, as they see themselves as the only ones that care about it. Autonomous monitoring may be sustained over time because it's based on intrinsic motivations to protect the forest. And autonomous monitoring can happen even when there is no land titling or external funding or rights, but this could also be beneficial to sustain it. So autonomous local monitoring should be regarded as an effective option for conservation strategies. The results of the monitoring and the achievements of the and will be shared in another lecture on the 21st of May at 6 p.m. And here we're going to talk about community monitoring of natural resource systems and environment, and also the potential use of this kind of data in law and advocacy. And we're going to do this presentation together with Systasis, an NGO from Italy, that they also have very good experiences with using citizen science data in court. And I would like to emphasize that the monitoring needs that are needed in Ukraine during and after war could be very different to this one. However, this case of Cambodia also can bring very good insights, and maybe the process can also be helpful to develop a monitoring tool involving local communities also in Ukraine. So I think that maybe in Ukraine, the environmental monitoring targets might be others, for example, land and water contamination, after industrial and energy producing facilities have been destroyed. And as I said, I think that still from this case, we can learn what works well, what challenges can be expected when involving in this kind of projects. And for more specific cases on environmental monitoring in Ukraine, you are very welcome to join other GROMADA lectures. They are posted in the websites, and they are also happening every week. And you can also join the workshop given by CEOPS, the Conflict and Environmental Observatory. They are giving a workshop on exploring the environmental data ecosystem for citizen science in Ukraine on April 17. And you can find the info on the online lectures in our website. So maybe to finish this lecture, I would like to introduce the lessons learned from this project and from other citizen scientists with whom I have been working that cover citizen science projects in fragile contexts globally. And these, I think, are useful insights that can also help us continue the work in Ukraine. So regarding methodology, what we found that works well is to use a co-design approach, which is essential to bring together different knowledge systems and for co-producing knowledge. And it promotes inclusiveness, brings diversity, long-term participation, motivation, and breaks the hegemony of scientific knowledge. And this is important. It is also very important to allocate sufficient time at the beginning of the initiative to get to know the local context, build trust, and bring all views in with equal status. And we recommend using simple data collection methods, simple technology, and simple interfaces and icons, so a wide range of people with different literacy levels can participate in citizen science. We have, of course, encountered challenges in our field, and some challenges are learning opportunities, and others are ongoing research questions that need further discussion and consideration. So these challenges are going beyond our case in Cambodia. These are challenges that also other citizen scientists have encountered when working in conflict zones and difficult contexts. So first of all, many challenges are posed by the fragile context itself. For example, political instability or challenging working conditions. Sometimes it's hard to get permits. And we also face power struggles when working with the powerless and marginalized people. And people often risk their lives to document illegal activities, which shows how important these initiatives are to them. And the design of apps that fit local context, it also requires a lot of time and consideration. And the language diversity poses both a challenge and an opportunity, because we have to find ways to communicate and understand each other, even though maybe the terminologies do not always translate. But it also brings an opportunity as we can appreciate an alternative way of describing the environment. There are also intellectual property issues. It is important to acknowledge the contributions correctly and appropriately, and to protect sensitive information. For example, local and indigenous knowledge about plant uses should be protected by Creative Commons or other kinds of licenses to guarantee that the communities have control over that information. And we should also consider the validation systems. Who decides what data is valid and why? And finally, we need to consider also the ethical aspects. That citizen science in fragile contexts introduce new power imbalances at the local area. For example, who takes the decisions and how? who facilitates the process, and who is the interlocutor, who is counted in and who is left out. And these are ongoing research questions and considerations for practitioners. Citizen science in fragile contexts also naturally brings opportunities at many levels. Citizen science applications can become advocacy and leverage tools for local people in fragile contexts, which promotes empowerment, outreach, and dissemination of local knowledge and realities, and can achieve a great impact. Empowerment comes through proper methodological protocol, and local participants should take complete control and ownership of the initiative from start to end. Data ownership by local peoples increases the responsibility feeling, data quality, motivation, and long-term engagement. And as I said before, the language barriers or the language diversity can also be an opportunity, because by including different knowledge systems, different languages, and worldviews, we can appreciate and learn from different ways of understanding, describing, and living the world. And just to finish with some good practices, we have learned that it is very important to involve local people right from the start, to follow bottom-up approaches, and to address local needs. And it is very important to spend quality time with local participants, to trust each other, and to have reciprocal communication. The local context needs to be fully understood and appreciated prior to the design of ICT solutions. And this can only happen with the full and active involvement of local communities in all stages of the project implementation, as well as taking a transdisciplinary approach to support the design and implementation of citizen science initiatives. The collaboration should promote local knowledge and agendas instead of unilaterally transforming local knowledge to fit global agendas. And we should also pay attention to the new kinds of social norms that emerge at these collaborations. We should always follow research ethics and codes of conduct, like free, prior, informed consent, and respect local customs. It's important to think of low-tech solutions and solutions that allow data sovereignty, and to follow iteration loops and constantly re-examine the goals and the means. It's also important to be humble and to recognize and allow other forms of knowledge, and to be patient with ourselves and others. It's a long and challenging process to engage different actors and stakeholders in citizen science, but the effort is well worth it. If you would like to get a bit more hands-on experience on how to build and set up an environmental monitoring app involving local communities, and then get also in-depth knowledge about the legal framework on environmental protection during and after war, do not hesitate to join the GROMADA Summer School in Hamburg, happening this August. You can find more information in the website. And I really want to thank you for your attention, and please make sure to check the website and LinkedIn profile of the group. Here you have also my email address. The next lecture is going to be on the 8th of May on Greens, Human Rights and Armed Conflicts with Anne Dienelt from Hamburg University. And I will also have this follow-up lecture on the 21st of May that I will introduce a bit more about the results and what the PLCN has achieved during this time.